You type one sentence, press send, and a few seconds later an answer begins to appear. It feels as if your message went straight into AI model. But in real AI application, the model is usually only one stop in a much larger journey. So what actually happens between your click and the first word of the answer? First, the application receives the request. Before it reaches a model, the system may check who is asking, whether the user has permission, how large the request is, and whether the service is already overloaded. It may also apply rate limits, attach a request identifier, and decide which parts of the product are allowed to handle the data. This is the application layer. The AI model has not seen the message yet. Next, the application assembles the model's input. Your latest message may be only one piece. The system can add instructions, recent conversation history, a file, relevant memory, formatting rules, or other context the model needs. For our question, the report itself is important, but sending every page may be noisy and expensive. So the application may first select only the sections most relevant to risk. The small message you typed has now become a much larger context bundle. Some requests need information the model doesn't already have in its current context. The application may search a knowledge base, retrieve document passages, call a company service, or ask a tool for current data. Those branches are optional. A simple rewrite may need none of them. A question about a private report may use Retrieval. A question about today's weather may require a tool. The important point is that the application decides what additional information or capability the model needs. The request may still not go to the same model every time. A routing layer can choose between a faster model, specialized model, or a fallback service. The decision may depend on the task, input size, latency target, cost, language, or whether an image is attached. This is one reason two requests inside the same product can take different paths. The router is choosing the service, not answering the question. Now the selected model service receives a context. The text is represented as tokens. A service layer schedules the work and sends it to the available computing hardware. In production, many requests may be queued, grouped, cached, or balanced across machines. Then the model begins generating output tokens one at a time. This is inference, the point where the model actually performs the computation that produces the answer. But the answer is not necessarily shown to the user all at once. As output tokens are generated, the application can stream them back to the interface. That's why you often see the answer appear word by word. Before or during delivery, the system may also check formatting, remove unsupported content, attach citations, enforce a structured output, or block a result that violates a rule. Not every product performs the same checks, but production systems usually need more control than simply displaying whatever the model generated. Around the whole journey, the application records what happened. Teams need to know where time was spent, which model was used, how much the request cost, whether Retrieval found usable evidence, and where an error occurred. And errors do occur. A model may be unavailable, a tool may time out, Retrieval may return nothing, a production system can retry, use a fallback, return a partial result, or clearly tell the user that it couldn't complete the request. Reliability is part of the product too. So the chat box is only the visible surface. Behind one answer may be an application gateway, a context builder, retrieval and tools, a model router, inference infrastructure, output checks, streaming, and monitoring. Not every application uses every component, but the central idea is the same. The model is only one part of the AI product. Your message enters the system turns it into an answer.